Good morning, everybody. Happy Friday. And today's topic for the tips and tricks call is policy optimization performance. And we're going to focus on the pitfalls and how it can affect performance on the gateway as you tend to create your policy. And today's presenter is a regional architect from the Mid-Atlantic, Dan Taney. As always, you guys are muted, so if you do have questions, be sure to ask them in the Q&A in the Zoom window. And with that, Dan, I will turn it over to you.
All right. Thank you, Kyle. So pleasure to be with everybody this morning. Happy Friday. So I've got a lot of stuff here, so I want to get right into it. But as Kyle said, I'm Dan Taney. I'm one of the regional architects supporting the Mid-Atlantic and federal accounts for Checkpoint. I joined Checkpoint last August, but was working as a customer and have been using it for over 12 years now. So a lot of what I'm kind of presenting today is a mix of some things from my own personal experience, some things from an internal session we did on performance and troubleshooting, and one concept that I'm borrowing from a good friend of Checkpoint's, Mr. Tim Hall. So give him credit where credit's due when we get to it, but let's get things started. So real quick, just high level agenda. We're going to do some quick terminology review just so we're all on the same page. And then from there, jump into a couple different topics that I think are very relevant to performance and things that can cause issues and maybe, you know, slow down your gateway, slow down your traffic, or just have you not get the most out of your Checkpoint investment. So real quickly, some terminology. Don't want to go too long on this, but make sure we all understand some terms. The first one's Core XL. Core XL is one of the pillar Checkpoint technologies on the gateway that allows us to increase the gateway's performance by leveraging multiple CPU cores, including hyper-threaded cores. And we basically do that by replicating a copy of the whole firewall kernel on each core that we've allocated to Core XL. There are two different types of core tasks that cores can perform on a Checkpoint gateway. The SND, which is the secure network distributor. A lot of people, myself included, say dispatcher. I guess either one's okay. The SNDs do a lot. They process all the incoming traffic from the NICs on the gateway. For the traffic that it can optimize, the SNDs are where Secure XL happens. So all of the Secure XL flows go through the SNDs, and then they also have to handle distributing the traffic that is not accelerated to the FWK. The FWK, or firewall worker, or Core XL instance, again, a lot of these terms used interchangeably, are the other task that inspect all the traffic that is ineligible for Secure XL acceleration through the slow F2F path. So then what's Secure XL? Secure XL is Checkpoint's acceleration solution that really maximizes performance of the gateway without compromising security by allowing traffic that has been matched previously to move to a more accelerated path and not have to go through the whole inspection process every time. And so kind of quickly here, you know, this yellow arrow would kind of indicate a not Secure XL or not optimized flow. And we can see all the different layers of the Checkpoint stack and the OSI stack we have to go through for a non-accelerated packet. It's got to go up the stack through the kernel and then basically back down again. In Secure XL, we really cut that process way down, and we can basically take the traffic from the NIC, push it through the acceleration device, and then back out the NIC on the other side through the Secure XL path. So, this can be a big CPU saver and performance benefit to not have to take that full path every time. So last, we'll just kind of hit on some gateway traffic flows because I'm going to be referring to these throughout. So the slow path, which is the F2F path. F2F is forward to firewall. Simply, this is all of the traffic that cannot be accelerated through Secure XL. The medium path is a little bit more of a gray area, and I'm going to spend a bit of time clarifying that. But this is basically packets and connections that require deeper inspection that cannot fully utilize the accelerated path the whole way through. So this is usually traffic that has to get offloaded to our passive streaming library. And that is usually as the result of use of blades in the NGFW suite, app control, antivirus, NGT, and NGTX, etc. And then the accelerated path, also referred to as the fast path, and that is basically SecureXL. So that's the fastest, most optimized path any traffic and connections can take through our gateways. There are a few limitations of SecureXL, and this is where I want to kind of focus on this for a second, because what we're going to try to do as we go through the different topics today is look at these limitations and how we can overcome many of them by leveraging policy and making sure that we're doing things optimally on our gateways. So the first one, and this is a big one, is that the first packet in any session cannot be accelerated by SecureXL by default. And if we think about this, it makes sense because it's a first connection. We're a stateful inspection firewall. We want to see the full TCP handshake. We want to go through, the full deep inspection and make sure that this is a valid connection. So by default, normally we would never accelerate the first one unless we have acceleration templates. So we'll talk about that. The next one is matching rules can be a limitation of SecureXL. Maybe surprisingly to some of you, drop rules are not accelerated. And we'll talk about that and how we can use drop templates to overcome that. Other ones would include where the gateway is in the source or destination of the rule. There's not much we can do about that one, but I mean, if you've got your stealth rule in place, there shouldn't be a lot of traffic going to the gateway itself, other than just some of the checkpoint traffic, management traffic, maybe your user check in interactions, but there shouldn't be a ton there. Lastly, if you're utilizing user or session authentication. Now, some people might not even know what this is. This is kind of a legacy feature in Checkpoint. I think right now in Smart Console, you actually have to go under a submenu that says legacy authentication to use this. So those rules cannot match or cannot be accelerated. There's some VPN restrictions. We're not going to cover those today, but they're in the SK, so they're on the slide. And then the last two that I just want to throw out are packets and connections related to ISP redundancy and cluster XL in load sharing mode with sticky decision function enabled. And there's not much to say about these two things other than they can be big performance killers. And, I would encourage if you're using either of these or if there's thought about it, that there might be better ways to accomplish some of these things like ISP redundancy, for example, moving that up the layer and taking advantage of, routing functions like BGP and kind of offloading that redundancy to get it off the firewall, just because the restrictions with SecureXL can be a little, a little bit of a killer. And same thing with load sharing. You may not be getting the performance benefit that you think you're getting if you're doing active in load sharing because of the way that a lot of the traffic is not getting accelerated. So we'll just move on from there and get into templates. So this is kind of the first important thing to understand. Remember, is the first thing we looked at with things that prevent SecureXL. New connections were one of them. So there's three different types of templates in SecureXL. And first of all, are templates enabled? You can just run fw stat on your gateway and you'll get a screenshot that looks like the one here on the slide. And the things we really want to focus on are the accept, drop, and NAT templates. Are these enabled? All three should be to get the best performance. But what do they do? Accept templates are able to cache rule-based lookups so that sessions that have basically already been established or connections that have already been fully inspected, we can establish subsequent connections through SecureXL without having to send them the full F2F path every time. So this can be done without having to do the whole rule-based lookup and then thus accelerated. So this is kind of a big one because, we're able to reduce CPU overhead and skip that full rule-based evaluation. And one thing you're going to hear me say over and over again through this is how costly rule-based lookups are from a CPU standpoint. They just take resources. So the less rule-based hits we can get, the better. NAT templates are very similar to accept templates where we're caching NAT lookups. And these two kind of go hand in hand. So we want both to be enabled to get the best benefit out of it. You can use this command on the slide, fwtab -t fwx cache-s. That will show you basically the stats on your gateway for how NAT templates are being used. The last one are the drop templates. And this is another important one because by default, drop actions have to be done in the F2F path. And, you might think for a minute, well, wait a minute, like, dropping traffic is good. We want to not pass traffic we don't want, but it comes at a bit of a CPU and performance cost because drop decisions have to be done more at the packet level and not the connection level. And again, if you think that makes sense, because some things that we are dropping would be out of state packets or, where a TCP handshake was maybe never even completed. So it's very likely we're dropping way more than, if we were looking at just connections, because there's a lot of things, especially if it's an internet gateway, that we're probably blocking and dropping before the full connection even gets established. So because of that, it requires a rule-based match for every new packet that comes in. Again, rule-based lookups are expensive. So if we enable drop templates, we can accelerate the drops into SecureXL, same way with the accept templates. If we're dropping the same thing over and over and over again, the gateway can say, hey, we already made this decision. We dropped it once, we dropped it twice. We don't need to keep inspecting it. So this one's really easy to turn on. If you just edit the properties of the gateway, go to the optimizations section, check off enable drop optimization, push policy, and you're good to go. And now drop templates are enabled. I'm not sure honestly, if there is a point where this is turned on by default in the various versions of Checkpoint, because in my own experience, I kind of always turned it on early on. So it might be that in a newer version, this is enabled by default. I'm not sure. But again, if you do the fwxl stat command, you can find that out and see if you have it turned on. So all this is great so far, but what happens if there are templating violations? Because just like there can be SecureXL violations, we can have things that block templating. And you would see this in the fwxl stat command. And in my example here, you might see accept templates are being offloaded from rule number 8. Now, a misconception that I even had was that this meant anything below rule 8 could not be accelerated for SecureXL. That's not the case. The traffic itself can still be accelerated, but what this means is nothing below rule 8 is eligible for templating because it's being blocked. So, if this is a 10 rule policy, that's not a big deal. If this policy has hundreds or thousands of rules in it, it could be a huge deal that we're blocking templating at such a high level. So you can go through and you can see in my example that basically this rule is just using a service, all DCE RPC. It doesn't even really matter what that service does. I just used it as an example because it's something that would block templating. So if you go in and look at this, at the stats on your gateway, and you see that it's being blocked, you can either first look at the rule and see, do you really need it? Because the easiest thing would be to get rid of it. If you do need it, move it as low in the rule base as possible so that we're not blocking templating for as much of the policy as possible. And, once you do that, make a change and push policy, you can always go back, check your stats, and you should see that changes now. So again, some things that can limit templating. A lot of this is legacy stuff. In the interest of time, not really going to go through this. This is in the SK, and I'm sure we can, if anyone needs it, we could either get you the slides or get you, this at a later time. So let's talk about medium path. And medium path is interesting because it's kind of a mix of both FWKs and SNDs. So, this is when basically data packets have to be redirected to a worker to build the whole TCP stream for further inspection. So a good example of this could be the content awareness blade, where basically we're looking for, hey, is this file match certain criteria? And obviously, the gateway can't make that decision until it has seen the whole stream, because we don't know yet, is it an Excel file? What's in it? In this example I have here of this rule base, we have rule number 1 is showing we're going to block executables, and it's in any service out to the internet. So we have 2 possible matches here, where the first match is going to be the one we're going to hit. And because of that, all of this traffic going out to the internet is going to hit the medium path, regardless of, what it is, because it's such a generic rule. And so, this is kind of an example of a rule that's not written very well, and that ideally, we might want to try to hone this in a little more to be more specific and say, if it's going out to the internet, like over file transfer protocols or to, Dropbox or something like that. Because right now, as this stands, there'd be a better rule for it to match on rule 3, but it's never going to get there and go through the full fast path, because this rule above it is this content awareness rule that's going to inspect literally every connection going out to the internet. So with medium path, again, it involves both the SND and FWK processes. So unfortunately, it's in many cases, it's inevitable, because the more software blades you turn on, and we want you to turn more software blades on, but the more you use, the more likely there is that traffic is going to have to hit this path. So it's, it's kind of a double-edged sword, but there are still some other things we can do to make sure we get the best optimization. Real quick, again, another important point is gateway topology. It's important that you have your topology defined correctly, because if you don't, it's possible that traffic that you think would be getting inspected may not be getting inspected, or the other way around, and we're inspecting things that we shouldn't be. Most importantly, I want to call out this interface leads to DMZ checkbox. If this is checked or unchecked, in the threat prevention policy under protected scope, there's an option that you're going to say we're going to inspect all traffic or inspect traffic that is going external and DMZ. So if you have external and DMZ set in the threat prevention policy, it's important that interface leads to DMZ is checked off, because that is basically what's going to clue your policy in that this is a DMZ, inspect it with this threat prevention profile. So if this isn't set right, again, we may not be inspecting what we think we are. So there's been also a lot of confusion and talk about the change in rule-based logic and how we match rules in R80 versus the old R77 days. And in R77, it was just pure top-down, right? We're going to go through and figure out the first rule we match to and then hit on it. And that's how it works. Now, R80, we're using this column-based matching where we're kind of doing 2 passes through the policy. And the first pass, we're excluding any rule that couldn't possibly be a match. And then the second pass, we're doing that kind of deeper evaluation to figure out which is the right rule to match to. So any rule that can't be excluded the first time, needs to take that second pass. And this is where we can see a huge, a performance bottleneck with the use of any, because any rule that has any is going to pass into that second phase and need to be evaluated a second time. So even though we've optimized the rule flow and rule matching, any can still be a killer if it's used frequently enough. So, if you're going through and trying to optimize policy, really take a good look at where you're using any. App control. So I can't have somebody answer this question, but I'll just throw out there, what is the performance difference between these two logging options in an app control rule, where we have extended log versus log. And the answer is that using detailed or extended logging forces all the traffic going through that rule into the medium path. And the reason for that is that the details that need to be collected to write a detailed or extended log require the traffic to go through the passive streaming library. So this means if you're just kind of doing this to just, if you like just having the extra logging information, you're slowing your traffic down by making it go through that extra scrutiny. So I would say, go through, evaluate where you're using log versus extended log, and, really question, do we need this? Because it could be a bit of a performance killer. Also for app rules, I would say you want to always have the destination be internet whenever possible. This really would prevent any LAN traffic, LAN to LAN traffic, from getting mixed in and matching a rule that would pull it into the medium path. So when you're using internet, if it's something for like Dropbox, there's no reason for the destination to be any, because there never would be Dropbox like internally on your network. So use the internet object in destination and scrutinize where detailed and extended logging are used, because it could be forcing traffic into medium path that otherwise wouldn't be. So another one, and this one, I'm just going to give Mr. Tim Hall the credit. This is his concept. This has come up on Checkmates a number of times. So once again, another question to pose: that what is the performance difference between these two threat prevention exception options? So the first one we have a profile, let's say a theoretical backup server going through a profile called Null TP profile. The other one is we just have an exception in our global exceptions for that backup server. The answer is that the difference is threat prevention exceptions only affect the decision on threat prevention blades. It doesn't prevent the traffic from going through and being inspected by all of those blades to make that decision. So, if we're trying to say, okay, we want the fastest performance for backup traffic, we don't want it inspected by TE, TX, all of that. The exception is not the way to go, because all the exception is going to do is say that no matter what decision gets rendered by those blades, we're always going to allow it through. So we can create this null profile, which is another threat prevention profile that just has literally all of the threat prevention blades unchecked. And when we put the rule in that way, when the traffic matches this profile, we're not inspecting it by any of the blades. And so this can very much increase the possibility that this traffic would be eligible to be accelerated by SecureXL, potentially keeping it out of the medium path. And this method does not require use of the SecureXL fast accelerator. I don't really have time to go into what that is, but this could be a really valuable way to really look at your rules and say, if you're using threat prevention exceptions to try to just have things not be slowed down, you may not be getting the best bang for your buck. And we're starting to run low on time. I want to be able to make sure we have time for questions. So I have one last thing to throw out here, which is geo policies. I love geo policies. When you can use them wherever you can. The traditional geo policy section of the gateway is implemented ahead of the access policy. So what that means really is that before we even get to a rule-based match, and remember, rule-based matches consume resources. Before we can even get to the rule-based match, geo traffic would drop first. So this is the fastest, most efficient way to discard unwanted traffic off your gateway. So, if you're fortunate enough to be, in an organization where you can identify, we don't, do business with these countries, we don't need this traffic, rolling it off the geo policy is the fastest way to just get it out and clean it up. If you can't do that, there's also, I believe from R8030 and up, updatable objects for geo. And this is the screenshot on the right. You use this in the actual access policy. So instead of having everything handled by the geo layer, You can do it in the access policy. It's much more flexible than doing it on Geo, because you can write more granular rules, but you don't get quite the performance advantage that you would by having it go ahead of the policy. But consider Geo. It's very powerful. You used to have IPS for it. You don't even need that anymore. So any gateway can take advantage of it. Lastly, just some final considerations. Again, use of any, try not to do it. Restrict your rules as much as possible. If a rule has to match just internal traffic, there's a couple things you can do. You could just consider creating a network group of just the RFC 1918 networks. And even just by doing that, you're restricting the possible matches down to just internal LAN networks. So you could do that if you're organized enough or your network's not so huge. You could even make a group that just contains all the subnet ranges that you use in your organization. And remember, you can always negate objects in a rule as well. So, you could do not the 10 network or not something just as easily to avoid and clean up your use of any. R80 is much better with performance in rule-based lookups than previous versions, but there can still be benefits to rule and object cleanup and rule placement, as we saw with what can happen with templating. So use FWXL stat, make sure that you're not blocking things that don't need to be blocked and you're getting the most out of your template feature. And lastly, NAT templates were enabled by default in R8020 and up. But depending on your gateway version, I would just check. It should have been done automatically, I believe, in R8020 and up. But if it isn't, you may have to do it manually. And there are some great docs on how to do that. So I know I might be taking everybody a little bit long here. I apologize. It was a lot of content to get through, but we're here at the Q&A. So I see there was one question here. Been told that geo policy is moving away and more to updatable objects. Is this true? I don't know definitively. I haven't heard that one way or the other. I could certainly try to find out for you, but I apologize. I hadn't heard that. So are there any other questions?
Thanks, Dan. So we do have actually a couple other questions. What about as far as the performance goes with everything you discussed, any negative effects of IPv6 being enabled?
So that is kind of a whole topic for probably a whole topic for itself, in that, there's the IPv6 cores, and so I'd say that might kind of unfortunately fall out of the scope of what we're able to talk about here. But I think, again, like a lot of, I don't think there's any negative effects in terms of in terms of that anything I'm suggesting that you could do would be detrimental in an IPv6 environment. I think all of this stuff pretty much would transcend, all of those different concepts, but maybe just looking at your the allocation of IPv6 cores and, seeing how the same kind of performance monitoring, but nothing I suggested here that I'm aware of would be different or have a negative impact on IPv6.
Okay.
I see there's a question in the chat from David. Would there be a difference between negating RFC 1918 object versus the internet object? That is a great question. And that's actually one of the things I didn't have time to get to. So I'm glad you asked it. The internet, and this goes back to the importance of topology. Generally there's the internet object, the all_internet object. Those objects are basically dynamic objects that are composed and put together based on the topology of your gateway. So if your topology isn't right, it's possible that the use of the internet object may not work the way you expect it to. So yes, I would say the difference is that if you're negating RFC 1918, you would be excluding any 10, 172, 192 network from matching the rule, whereas the internet object is going to be I believe basically any routable, so basically any not RFC 1918 that's not used in the gateway's topology. So the internet is a little bit more refined in that it is, topology specific, if that helps. So it's another good reason why, if you're going to use internet, to make sure that your topology is correctly defined. But from a performance standpoint, there may not be a huge difference. I think there's actually a thread on Checkmates that is pages long about people debating using RFC 1918 or negating RFC 1918 versus internet versus all internet. And, some of it may just come down to your preference. But, you're kind of, if you're doing any of those things, I think you're on the right path to, kind of honing your rule base in and, getting rid of any's.
Great. Thank you.
Did you have anything else, Kyle, from your side?
No, I think that covers all the questions that have been asked. So I want to appreciate everybody for taking the time to join today. Dan, thank you. Great presentation, and thank you for participating today and being a part and sharing the information. As always, this has been recorded for everybody. So if you do want to replay, please get with your local account team, and they'll be able to get you the information. We'll have another tips and tricks call in 2 weeks on June 18th, and hope everybody has a great weekend. Thank you for attending. Thanks, Dan.
Thanks, everybody.